Hey, welcome back, everyone. We are now starting with our roundtable discussion on sustainability challenges for innovation in urban mobility. And we are very happy to have with us Cyril François from LVMT Pont Paris Tech, Stéphanie Jumel from EDF Lab Paris-Saclay, Alexandre Vaudrey de l'ECAM Lyon à l'Université de Lyon, et Flore Vallée, que vous avez déjà vu, chercheuse senior dans l'équipe de la chaire Anthropolis. Donc, avant de poser des questions un peu plus précises, je voudrais vous inviter à...
Jacob, you're in French.
Ah, yes, sorry. You see how French I am already? So thanks for telling me that. So now switching to English. So welcome to all the participants to our roundtable. And so I would like to start with a round of initial statements. So the first statement will be by Alexandre. Right. So do I have slides for Alexandre?
I have mine if you want.
Ah, yeah. So if you want to share,
if I can share this.
I know. Sorry, the first statement is Flore Vallée. Sorry, who will present the position of the chair. So I thought you will share the slides, Flore. That's why I'm a little bit.
Oh, sorry. Yeah, you no wanted problem, me to do that. Sorry.
No, yeah, but it's not a problem, and I just do it, but it brought me out of my concept. So please, Flore, go ahead with the presentation for the chair.
Okay, thank you, Jacob. Okay, so first of all, I go back to the backbone of our research you've seen before with the different tasks. Just to position what we consider in our work. Sorry. So in fact, we consider, of course, mobility, but also immobility. And important to know, we consider resources in a broad sense, which is the physical resources, material, energy flows, but also the digital resources, such as data. And we want to consider vehicles, infrastructures, and also the usages, which are really important to the chair. And here I mentioned the impacts, which are negative impacts, but we're interested in the duality between mitigating negative impacts and creating sustainable value. So for urban mobility futures, we would be interested in social impacts associated with mobility and also notably questioning the idea of equity for different social groups regarding our future scenarios. For mobility as a service, we'll be interested in the sustainability of mass business models, but also something which is quite new in the field of IT is the environmental impacts of mobility data associated with the production of data, storage, and analysis of data. And regarding infrastructures, we will be interested in more specifically in the environmental impacts of joint infrastructure and vehicles, which is also quite new in the field of eco-design. So we're interested in more in the aspect of eco-design and with an application for electric mobility in a project we're conducting right now. And there's a second slide, sorry, on another subject where we want to point out. So given the limitation of resources, we will be interested in debating about the appropriate balance for our societies between what we entitled high-tech and low-tech for sustainable urban mobility. Here we designed this special issue in collaboration with Dr. Henriette Cornet from UITP. And so calling for contributions on this topic, because we think and we want really to reflect upon the choices between high-tech, for example, automated vehicles or shuttles, and more low-tech solutions based on usages and not relying so much on technology. And we want to see what is the right or the appropriate balance depending on the context, and what are the impacts of high-tech and low-tech mobility solutions, also depending on the viewpoints for citizens, for local or public authorities, and also for mobility providers. So it's also a call for contributions, because the call is on until August 21. So if you wish to advertise for the call or contribute, please do. That's it for me for now. Jakob, you
Thank
mute.
you, Flora. Yeah, I just had to find the unmute button. So thanks a lot. And now next input statement will be from Alexandre. So we have your slides.
Yeah.
Maybe I can share mine, or you want to manipulate the slide?
Yeah, I can now. Let's stay like this and just see next slide. And
okay. So
not to complicate things further.
Okay. In few words and in a few minutes, some thought of ideas I want to share with all of you about energy and urban mobility, but from the point of view of machines. So in few words, I'm Alexandre Vaudrey. I'm senior lecturer at the Lyon, which is a school of engineering. I teach mostly about thermodynamics and all which is related to energy topics with machines. Sorry, so I'm really more focused on machines. Sorry. I work for some time on fuel cells. Now I'm more interested into internal combustion engines. And so the few points I will explain in the coming minutes are really related to infrastructure, to machine, and to the flows of energy. So next slide, please. Okay, let us represent transportation infrastructures as a sort of change, the sort of flows of energy from natural resources to final utility, so to movers. Okay, so on the left you have the natural resources. In the middle of the slide you have the energy carriers, which are used in order to just transport, to store this energy for the duration you need in order to propel your vehicles. And from on the right you have the movers. And for the moment, to date, almost the only infrastructure which is used on a worldwide scale is the upper part. So it's fossil fuels, it's hydrocarbon fuels, mostly liquids as energy carriers, and all of this is burned into internal combustion engine. And we perfectly know all the drawbacks of this kind of technology, all the effects on climate change, on air pollution, and so on. And so if we just want to think about the future and to imagine really better solution, probably for most of us, the first that come into mind is the lower part of the slide. So all which is electricity. Okay, it's the clean one, the green one, with low carbon electricity production, with some batteries as energy carriers, and with electric drive. So directly electric motors into vehicles. But there is another alternative, and a lot of people are talking about that currently, and it was one of the topic of the previous keynotes. It's hydrogen. Okay, so we can use hydrogen, supposedly using fuel cells, and these fuel cells are producing electrical current in order to propel electrical drive. But the question is obviously how to produce this hydrogen in a cleaner way, enough in order to supply all the energy infrastructure. So just imagine other kind of situation. Next slide, please. Okay, so this one is the complete one. Will it be possible, for example, for me to just buy an electric car? I checked last year, it's too expensive for me. It's too expensive for me. I cannot afford this kind of vehicle for the moment. And I'm not among the poorest part of the population. I'm not on the richest, but not on the poorest. And it's really too expensive for me. And for hydrogen, it's pretty much the same. This kind of vehicles are really complicated. They are really expensive. They are, for example, you have any kind of technical problem with the fuel cell. Where do you go if you want to just make your vehicle to be fixed? How to find a mechanic which is able to fix it? It's a really complicated question. So we will have solution, but it will spend a lot of time to come, or a lot of time. It will spend time to come, and it will require a lot of public and private investment for so. So what do we have as an alternative energy resources? One could be which could be interesting. It's biogas, okay, which is produced, for example, from waste from agriculture or domestic waste. Also, we can produce, for example, biomethane or biohydrogen, or we also have biofuels, liquid ones. But this kind of hydrocarbon fuels cannot be directly burned into fuel cell for some technical reason. And so probably we will still have to deal with internal combustion engines, but in a different way, okay? And so maybe some of you already saw some kind of articles in some journals for the large public explaining that internal combustion is dead, internal combustion engine is dead, and we will probably be forbidden in coming years, and in the future we will only have electrical vehicles on fuel cells. I'm really not convinced about that, for not only about not only because of the financial reason, but because of the nature of the fuels, okay? Because if you want to produce hydrocarbon fuels, for example, biogas, or maybe you want to mix it with hydrogen, it's called power to gas. It's another strategy which can help to store energy on the network, on the existing network of natural gas. This kind of gas, this kind of mix of methane and hydrogen, it's not really possible to burn it in a fuel cell, to consume it in a fuel cell. So probably we will still use internal combustion engine for the same reason. And probably it is also possible to use it with hydrogen. And there's another energy carrier, which is ammonia. So it's not really well known because it's toxic and it stinks, but for some specific application, it could be interesting because it contains a lot of hydrogen atoms, no carbon atoms, and it's liquid at atmospheric pressure. So for the density, for the volumetric density of energy, it's really interesting to use this kind of carriers. And so just with this picture, we can see that probably there is not only one solution, because if we are just thinking about the future, a lot of people, if you are just talking with them, say, okay, the future is only about electric vehicles. Okay, but why are you thinking so? Because I'm manufacturing electrical vehicles. Okay, this is a reason. What is the future for you? Oh, it's hydrogen vehicle. For myself, I really think we will have a lot of different solutions. So different vehicles, different movers. We will still have internal combustion engine. We will have fuel cell. We will have electric vehicles. We will have different energy carriers. Sometimes it will be batteries. Sometimes it's liquid hydrogen, high pressure gases, hydrogen. But why not also hydrocarbon fuels, biogas, and all of these energy carriers can be produced by a lot of different energy resources. So I would just finish with that. I made my point, but I just want to emphasize that in my mind, there is not only one technical solution. That will be a lot of different solutions. And so for this reason, the future will be probably really more complex, but at the same time, really more interesting, because it's a lot of different technical solutions we have to improve and we have to optimize for the use in future transportation. Okay, thank you. I'm pretty sure I just spent 4 minutes or something like that. Thank you.
Thank you. I didn't look extremely very strongly at the time. I think we are fine. So the next presentation will be by Stéphanie Jumel, actually, or maybe we do Cyril, because you have slides, and I don't know whether you have slides, Stéphanie. So then we start with Cyril.
Your mic is off, Stéphanie.
Yes, thank you. So I was. Thank you very much. So I'm happy if you can move forward, Cyril, and I will finish the roundtable then.
Okay, I will start.
Okay.
Hello, so I'm Cyril François, so I'm a researcher in the laboratory Ville Mobilité Transport in Paris-Tech. And I'm working on a mobility object, not as a technological object, but as a social and spatial object. And with that, I'm doing some environmental assessment of mobility. And one of my specificity is that I'm coupling mobility modeling with life cycle assessment for transport system. And by doing this, I can add some dimension to the mobility assessment, such as the spatial dimension, because with transport modeling and mobility modeling, you can understand where people are going, why they are going in this place, how the flow of vehicles is distributed on the territory. And you can also have some temporal assessment to know when people are going in this place and this kind of studies. So this is directly linked with territorial assessments. So with the use of mobility modeling, we can have a straight assessment of a territory. It could be a very small territory, such as a district, such as a group of industries, but it can be also a bigger territory, such as urban cities, metropolis, and bigger. And we also have the vision about social aspect and economical aspect, because we use a different object to describe the mobility. So we have the mobility with the use of vehicles, but we also have some information about what kind of individuals use this technology. And we have also information about the social economical parameters of different individuals. They are rich, they are poor, they are living in subways, in city center, they are employed or unemployed, and such a kind of information. We also can link mobility with industries. If, for example, some industries have specific mobility, we can link with that, with the kind of modeling. And the other aspect of my research is environmental assessment. And for that, I use life cycle assessment because we have a more systemic vision of environmental impact. And this is quite unique when we do that for a territory. Life cycle assessment is often used to assess technology, but not so often to assess a territory. So it's quite interesting to couple urban modeling with life cycle assessment. And then with that, we have a systemic assessment of the mobility with multi-criteria assessment. For example, with that, we can explain that mobility have an important impact on the land use with the infrastructure or the field need for biofuel, for example, for biocrops. And we can also show the impact of climate change and the impact of mineral and metal resources also. And next slide. By coupling the modeling, urban modeling, and the life cycle assessment, we also can assess different kind of mobility measure. We can, for example, implement different measure for modal choice to improve the use of active mode, such as bicycle or walking. You can also improve the public transport accessibility to have a more sustainable mobility system. We can also, with the life cycle assessment part, include different technologies such as electrical vehicle, new thermical vehicles, this kind of technology. But we can also add other measures such as urban planning by reducing the number of parking slots, by creating home office area, by creating more coherent area with by putting together the residential, the working area, and the leisure and area and shopping area. We can also have different measures for car use with, for example, car sharing or carpooling. And we also can imagine some coercive measure such as city tool, the price of fuel. By increasing the price of fuel, we have impact on the use of vehicles. And we can also imagine some regulation on the speed for vehicles. And with that, with the coupling of urban modeling and life cycle assessment, we can have a common methodology to assess this different kind of measure, and then to compare them on the same methodology. And this is what I'm doing in my work. And I think I'm going to stop this here for my presentation.
Thank you, Cyril. So I will now stop sharing my screen. And please, Stephanie, I give you the floor for your input.
Thank you very much. So sorry for being late. I had some connection issues, but let me introduce myself. I'm Stephanie Jumel. I'm currently managing the Research and Innovation Program at EDF, so Research EDF R&D. So Électricité de France, for those who maybe don't know it, is a world-leading company in power production, distribution and retail of electricity. EDF has also, let's say, launched in 2018 an ambitious plan, mobility plan, to accelerate the acceptability of electromobility, not only in France, but in Europe. And I just want to give some insight of what we're doing that will really make the link between the two previous introduction, I would say, between the motor itself and between and the energy planning at the regional level. On the other hand, I think we can say that EDF is just sitting in middle, just deploying the infrastructure that make electromobility like feasible, I would say. So, yeah, EDF main interest today is to deploy and operate, manage like a charging infrastructure for passenger cars. But in support to this plan, we also have an important research activity, research program, to improve first those equipment, to make the user experience, I would say, more, in a better, improve their user experience, and also anticipate the future of mobility. And coming back to the title, to the origin of this talk, when we're talking about sustainable, mobility for the future, I'm glad to say that, it's part of EDF DNA to think about sustainable mobility. First part of our DNA, is decarbonation of the overall economy, and in particular of transportation sector. So or any activity that we can have on electrifying the fleets, in supporting again the user experience, it's good. And through EDF decarbonized, I would say, power, we definitely contribute to this to the decarbonation of transportation. The other leg, the other part, that is important for us, EDF is really used to think in terms of global approach, global system. And as has been said with LCA, it's important to think about mobility as a whole system, as a system as a whole. Again, we do promote electromobility and passenger car, but we also believe that this can only be one part of the overall system. I'm glad I live in Paris region where there is a huge public transportation system, and I'm very glad to use it, but it's not the case for everyone. So we need to think, electromobility and decarbonation of transport, not only for passenger car, but for also, public transportation, and really see that as a piece of a big puzzle. And this is really important for us. This is again one leg. The last, maybe another point that I wanted to emphasize regarding EDF activity is to take into account the integration of electromobility in the electric system. Of course, a lot of people are afraid that all those electric vehicles may be challenging for the grid. So another example of what we're doing in terms of thinking in a big system, in a global view, is looking at making sure that the integration of electromobility will be compatible with the current electric system. And we develop a lot of software and solution to make sure that the charging will be compatible with the electric system again. So maybe if I don't want to take too long, keep in mind that I mean, EDF R&D is working hard on decarbonization and on integration of electric vehicle to the grid. And last thing will be making sure that the passenger car will be well integrated in the whole system.
Thank you, Stephanie. I now have a first question. As the different participants in our roundtable, they tackle actually very different scales of the mobility system. So for your activity, what is the relevant scale to tackle, and why your scale is also intricated, of course, with other scales? Yeah. So this would be my first question. Maybe Alexandre, would you want to start?
So I will just stay on the energy-related topic, because outside of this, I'm really not comfortable on. So I will just let the rest of the explanation to my colleagues. I would say it's a really easy answer, but I would say all the scales are intricated actually, because if we are just getting back to my previous explanation about primary resources on energy carriers, which are used, for example, for storage, on the final use, all of these flows of energy can be distributed at any scale among a country. So from the large production of electricity, for example, in nuclear plants that are used to charge electrical vehicles, that are used, for example, to produce electricity, to produce hydrogen, which is injected into, for example, power to gas network, on which is later used by another kind of vehicle. And so for me, the scale is from the scale at which we are harvesting energy. So from, for example, solar, from wind. So it's typically the scale, the dimensional scale of a country, to the final use. On probably the tiniest one we can imagine is, I don't have the English translation of trottinette, but I'm pretty sure this word is clear for everyone, with a really small electrical engine. It's probably the smaller kind of vehicle, of electric vehicle we use. And so we have all the scales, all the intermediate scale, from the large production of electricity, all the ways which are possible to transport it, to store it for different duration, depending on the final use we'll use from that. Also from vehicles. And for urban mobility, probably the largest one are trucks, and the smallest one are bicycles. I don't know if exactly if for all of you it corresponds to a large, different scales of size, but for me it's really different, because it implies a lot of different technologies for mobility, for the storage of energy, for the production of motion, the different ways we can use to mitigate the eventual pollution which is produced by this kind of technologies. So for me, it's about energy. It's about the way to use it in the most efficient way at any scale, from its production to its final use.
Thanks, Alexandre. So I think I now go back to Stephanie for the link with the energy scale, and then to Cyril for the, I would say, for the urban vision.
Yes, I agree with what just been said. You know, it has to be tackled at any scale. It can be very local, and we see opportunity. You know, for example, with PV, PV plus electric vehicle, because you know that there will be some PV production at noon, at lunchtime, where this is a good time maybe to charge your vehicle. And definitely the combination of PV plus EV PV will, support the full decarbonation of the system. It will promote, also give more opportunity with PV. This is, for example, what we see in California. So definitely at the super local level, like at the level of a house, there is something to do to decarbonize and optimize the system. We can mention maybe the neighborhood scale, that similar. You can have a bunch of electric vehicle or bus or trucks, or bus, let's say, and do some charging at the good time and combine with renewables. And of course, we need to tackle, and this is what I was trying to say with the introduction. We need to try to tackle the point at the large scale as well, like the overall electric system, to make sure we really have we don't have too much power requirement at a given time, but let's take it as an opportunity as well with renewable. The grid operator today have to take into account increasing number of wind energy, for example, which is highly unstable and highly unpredictable. What is really nice with electric transportation is you can control the load at the time that is the best for you. So definitely have a flexible load in front of a flexible power production. So I would say that the global scale also provide opportunity for decarbonation of transportation as well. So yeah, or any scale. And that is what makes it, complicated, but passionating, and passionating for R&D as well.
Yes, thank you, Cyril.
Yeah, scale, it's quite a broad question for mobility. And we see just before that the question of just the scale of the assessment, just the fact to include all the energy production is quite interesting for urban mobility, because most of the time, and territories just look at the direct emission of CO2, and they don't often include all the technology involved to provide all the energy, which is maybe sometimes fossil fuel or electricity energy. And this is one aspect of the scale, and this is why life cycle assessment and the life cycle vision is quite important to promote if we want to have this broader vision for mobility. And on my specific topics, also I'm looking at mobility as deeply as trips and at different level. So there is, of course, for me, the smallest level is the individual one with specific behaviors, specific location, and there is specific use of technology. Sometimes this technology will be active modes, but sometimes it will be electric vehicles, and the solution for at individual scale will be very different depending on the social and economical parameters of this individual. So maybe he will be rich, as you say, Alexander before. Maybe he will be rich and he will have the opportunity to have an electric car. Maybe he will be poor and unemployed, and he will just have to work to find his food, just a block of road further. But it will depend of many parameters, and then we can build by increasing the scale. Some individuals, we can have the household with the different individuals in the household, so maybe some children, some parents. Then we have the district with the combination of different individuals, and then we have different policies that we can put in place. Maybe we can have some parking solution by reducing parking. Maybe we can put some bike station. Maybe we can put an electric charger in this district. Then we have the city level, and then we have the regional level, and maybe we can go to the national level. But in my case, I just looking from individual to cities and urban area level, and then we can see that there is depending on the scale that we look, there is no one single answer for mobility. We have a lot of solutions, and then the difficulty is to find the right solution for the right scale, depending on the need and depending on the different parameters, the social aspects, the spatial parameters.
Thank you, Cyril. Flore, do you have some comment on this aspect?
Yes, thank you. In fact, I'm much in line with the approach of Cyril with our work with the chair. I would point out two main scales in line with our previous work, taking a look at the individual user or citizen in its interaction with mobility services. So it's linked with the fact that we established the traveler experience model, and then it can be linked to a sustainable experience as well, assessing it. So it's much connected to what Cyril just said. And on the other hand, I would give the example of the mobility usages on the territory. So the example of the project we're conducting right now, an internship funded by the EcoSD network, eco-design of sustainable, éco-conception de systèmes durables, I would say it in French. It's about eco-designing electric mobility usages, in this case for long distance rides. And we're just like Cyril, trying to have a specialized vision connected with life cycle assessment or environmental assessment, but beyond just GHG emissions. So going a step further. So that would be the two main scales we are currently interested in the chair.
Thanks, Flore. As a final question or final round, so we have not much time left, but I would like to answer in 1.5 minutes or so. So the question is about the future. So what do you envision for future studies towards sustainability? So what are the major stakes? What are uncertainty? What are the most important aspects that should be taken into account for a future of mobility?
If I can start,
yeah.
what makes me feel super excited is the coming of autonomous vehicles and shared drives. Not only on the technical points of view, and I know that there are still some challenge, regarding safety, and but what I really feel with this type of mobility, it's very inclusive to my point of view. Like it makes mobility accessible to any type of people, like the young, the old, like disabled. It provides autonomy to people in urban area. It could provide autonomy also in more rural or peri-urban areas. I really see, and on top of the social aspect, I can see also some better or more rational use of the land. Like replacing a lot of parking lots with maybe greeneries or larger pathway. So I feel really excited. I know that there are a lot of doubts still in France or in Europe, mostly for regulation and safety issues, but what I've seen in the US looks very promising. And I'm really much involved, and I know that EDF is also involved in a couple of demonstration projects. First of all, on public transportation, like autonomous shuttles. But I strongly believe that the future of mobility will go through like full autonomous and shared drive. So I mean, this I will see. I really see this type of vehicles in the future.
It feels like you are almost in an autonomous vehicle, right?
I'm not. I have my private driver, but
that's what I thought, right? So maybe Alexandre, your
Okay, my personal opinion about the future of transportation, but it's not only about transportation, it's about our use of energy, is a tremendous decrease of the use of energy, complete change on the way we are considering transportation. Just for the reminder, 85% of our current energy consumption worldwide comes from fossil fuels, 85%. On my personal opinion, it won't be possible to replace all of this energy by low carbon electricity. It's on the duration we have for so we don't have 3 centuries to do so. We have decades. And I'm pretty sure it won't be possible to do so. And so future, it's about walking, is about bicycle, maybe it's about horses. I really love horses. It's a really efficient and really ecological way of transportation. And for some specific applications, maybe we will be able to develop, to create new technologies, interesting technology, but it's a lot of complication. And I'm pretty sure high-tech technology, it won't be applicable to any kind of application. And so it will be a mix of new technologies for some specific case when it's possible to do so, of really old technologies. Probably we just forgot this because it's not fashion. A lot of people don't want to use this anymore, but it's still efficient from an ecological point of view. So probably we will go back to this kind of technology, and we will use energy differently. We will use transportation differently. I'm pretty sure in the future, in probably, I don't know, 10 years, it won't be possible. It will not be possible for me to travel exactly from the same distance as usual as now. Okay, so probably I will have to restrict, and probably once a year it will be possible to travel to the other part of Europe for vacation, for holidays, for example, because the resources of energy will be really different. So probably it's not the more optimistic point of view of that, but usually it's the role of engineers to just say, okay, stay calm. We have some difficulties with the amount of energy consumed. And so just to finish with that, the future of transportation is probably not exactly what we have in mind when we think about high technologies on new vehicle, on electricity. And probably we will be surprised to see some comebacks of robust and quite old ways of transportation, but maybe are really efficient. For example, boat on the river, big boats we have on rivers. It's possible to transport on this kind of ship hundreds of tons really easily. On a truck, it's only 40 tons, so it's not the same scale. And for consumption of fuel, which is really lower. So probably in the future, I live really close to the Saône River. It's 200 meters from here, and probably in the future I will see more and more boats of these ships to transport goods, because it's really efficient. It's quite slow, maybe it's not transported at the same speed as truck, but from an ecological point of view, it's really more interesting. And so for me, the future, it's a lot of surprise.
It's, yeah, pretty amazing for an engineer to think about solutions from the past rather than from the future.
Yeah,
so Cyril, maybe you want to add something.
Yeah, I'm not going to be so optimistic about the future also, but I think we have some keys to have a clear, better view of the future, especially with the retrospective vision of the transport. Now we know that transport have impact on many things. Transport have impacts on urban planning with the urban sprawl. We see the impact of transport on the global energy production. We see the impact of transport about the economy. We see all this kind of aspect of transport, and all transport innovation have impact on urban planning, energy demand, economy, and so on. And now I think we have developed, and you continue to develop some models, urban model, economics models, spatial models, to understand all of these bouncing effect of transportation, because we know now that every innovation in transport have bouncing effect. And the important for future is to understand this bouncing effect before we implement broadly a technology. Maybe the autonomous vehicle will have better. So it's a clear solution for the specific case, but it will have a very important balancing effect. For example, maybe we will have a huge urban sprawl. Maybe we need a large numerical industry. Maybe we will need we will need very much of mineral and metals to produce the vehicle. So maybe we will have all these balancing effects. And the electrical vehicle also have balancing effect. The public transport also have balancing effect. So we need to understand all these balancing effects to have a clear view at where we are going, and not to choose the easy solution to say, oh, it's quite funny to have an autonomous vehicle, so let's go for that, and we will see later if it's great or not for the environment. I think
it's not so easy.
I think we need to don't rush in transport innovation, because transport is central for the society, and if we change the society, it's hard to come back, and we can see today that it's hard to come back from the urban sprawl that we produce in the last years to a different society organization.
Okay, thank you, Cyril. Flore, maybe you want to have the last word of our discussion.
It's very kind of you, but it's a load on my shoulders. No, I would like, in fact, just to contextualize my answer regarding our work within the chair, and especially the work on urban futures with the PhD of Chuck. So bouncing on Alexander's view, of course, I think slowing down will be part of the future scenarios we'll be considering, because it cannot be ignored, this dimension. And in fact, what we're going to do is to use the sustainability dimensions, which we'll have to co-create in some ways to feed the development and the creation of the future scenarios we want to develop for our work. And I would like to finish on the social dimension without forgetting equity and inclusivity. And especially what I think is really a key topic I mentioned a bit earlier is about the aging of our European countries, but it's also the case for other continents, because it's about aging and it's about the future selves. So I think that's we have to consider, and I hope it's nice enough as a final word anyway.
Thank you, Flore, for this final word, and thank you everyone very much for participating in this final roundtable discussion of our colloquium. So this roundtable discussion ends now 2 days of really interesting presentations, roundtables, discussions, questions, and I'm really happy about how it went. And I just want to end on with an invitation, which is the invitation to our seminar series. So as you might know, we are organizing an online seminar every 2 weeks with our colleagues from the Future Cities Lab, also in Beijing. And it's a bi-weekly seminar. It's happening every second Wednesday between 10 and 11, and it's more of an academic-like style seminar series. So the next one will be on 14th of April because of the Easter break. And then we will go on with several presentations until end of June, and then we will go into a summer break. Do not hesitate to send us to join the Anthropolis mailing list. You can find it on our website, the link, and then you will get the invitation to the individual seminars. So I just wanted to make this invitation. Do not hesitate to follow us on our website, on our Twitter account of the chair. Stay tuned. There will be another colloquium next year, and hopefully we will see each other live and have some nice champagne or cocktail at the end not like today. Maybe everyone can, at his own home, have a nice drink this evening and think of the other colleagues. And yeah, anyway, so thanks a lot, everyone, and have a nice evening. And thanks a lot also
And
for the team and to the colleagues
just
who were all
little
involved in
question.
organizing this.
If
Yes.
because we wanted to say hi, to have our cameras on, so if people we would like to have their cameras on to say goodbye, it would be nice to have a kind of aspect,
Bye-bye.
human.
Thank you.
Thank
Bye.
you ever so much.
Bye.
Have a nice evening.
Yeah.
Have a nice
Thank you
weekend.
for
Bye-bye.
joining. Bye.
You
Bye-bye.
too.
Thanks a
Nice
lot.
seeing you. Thank
Bye.
you.
Thank you.
Bye-bye.